So I guess now for the crazy shit, right? So, develop QuickCover. What do we want to do, or what did we think about doing at some point? Basically, we wanted to see if we could do two things. Find out which lines of our code are actually being executed in runtime, not by static analysis, but actually running the code and somehow getting notes or a database of which lines were executed. And do that, hopefully without any large impacts in CPU or memory, because otherwise this is not going to fly, it's not going to be able to run in production environments, which is what we really are interested in. So, just as an example, real Perl code, and I hope you can see all the way in the back, Newton's square root method, math. This is, probably everyone saw this at some point in university, how to compute a square root.
You have such high opinions of all of us.
What's that? What's that?
You have such high opinions of us.
Yeah, well. That actually works. And it prints kind of like correct or seemingly correct values. So that code works. So what if we try to look at that code with Perl-mo concise? Everyone knows what that does?
No.
That's a module in Perl. You're saying no, you do. Okay. This is a module in Perl that will actually dump the opcode for you. So it'll go through the code and it'll tell you what Perl will do with your code. It's kind of like a decompiler sort of thing. So it does a couple of things, but in this case, we run that and we get that. And that's in a smaller font because you're not supposed to actually read that, because when you see that, you kind of like, I'm overwhelmed. That doesn't make any sense. So, second attempt, we just grep for nextstate. So, I'm guessing not all of you know what a Perl opcode is or the opcode tree is, right? Or maybe everyone knows? Okay, so, I'm gonna wing it here and good. So, when Perl takes your code, it'll generate something close to an abstract syntax tree, a parse tree or whatever you want to call it. So it will try to tokenize and parse the code, and it will create a representation of what the code will do. Perl has a set of previously known opcodes that will apply each of the little operations that your code is doing. So if you add two numbers, there's an opcode that will actually add the two numbers, and so on and so forth for many of the basic operations that the code does. There is one opcode called nextstate, which we suspected would be at the end of each line executed in your code. So if you run that and just filter for nextstate, as you see there, you'll see coming out of concise the file name and the line number that's being executed. So that looks like it could be useful for what we want, right? It looks like if we somehow could take the opcode tree and search for this opcode in particular, we may have the information that we need to record the coverage, the lines that are actually being executed.
Can I bug you? What's the other number? I can't help but want to know.
I mean, yeah. If you look at that, there's
Many
a
numbers.
boatload of more information in there. So I'm not going to spend any time on discussing that now. There's a lot of information you can get from concise. I really, really advise all of you to read the documentation for this, because it's really useful to understand what Perl is doing to your code. But right now we don't really have time for that, so I'm just going to politely decline your question. So, could we actually tap into that opcode for our purposes? So, in fact, it so happens that we can. There you have this exact same code that we were looking at before, but now we're using Devel QuickCover, just using the module. You will not see any other change in this code. And if we run the code, we still get seemingly right results, but now we get something else. If you go to your temp directory and list those files, you'll see that after you run the code, you get one file in there. The name encodes date and time and date and something else so that it's unique. That doesn't matter. But what's inside the file is a JSON piece of information with some metadata here, date and time, and some more stuff. But in particular, we get for each file that we went over, we get a set of lines that were actually executed. And if you look at that set of lines for this file in particular, and then look at the file, you will see that we actually got the line numbers that we were interested in. So all of those lines were actually executed. With some weird stuff, right? That closing brace there was not executed. That's probably because of the way Perl manages the opcodes, and there's no opcode for that baseline because there's nothing to be done there. So, but that minor detail, or maybe version 2.0 will take care of that. So, it works. How is it done? How do we do it? So, it's all a C XSub module. And there are basically two main functions that we have to take care of to do this. This function here is executed once, and it will install. It will do the magic necessary for you to actually install this thing. And this is executed, I will explain, every time you run into a nextstate opcode. So what do? First, in this function, we replace the routine associated with the nextstate opcode with our own routine. We remember the current value and we replace the value with our own value. Now, we are replacing in this array here, that is the array that Perl has with all the opcodes that it'll use as it creates your opcode tree. So it has like an array of, 50 opcodes. And every time it's parsing the code and it says, oh, here I have a nextstate, it'll go and take the opcode here, and it'll say, okay, I'm going to put that opcode in the tree here. Since we're replacing it in the array, what we're doing is that every time Perl will find that opcode, it'll use our function, which is this here, instead of its own function. So that's the first change we did.
Did you say in settle? You didn't hook on to call the previous implementation.
I'm going to explain that now.
Okay.
So what happens then as Perl now executes our code? When it finds an nextstate opcode, the first thing it will do, it will run the original function that Perl defines, and then it does something, and then it returns the value for that original function. So that way we're sure that we're not mucking things up with Perl, right? We don't actually know what that does unless you want to go and look at the Perl source code. But we remember to execute that original function and return its value. Now, of course, in between, we do what we wanted to do, which is register the current line, the current file and the current line in some data structure. I am not going to go into detail about that here, but it's a very simple bit set. It's a hash table of file names, and for each file I have a bit set of lines, so it's very efficient. And this is a minor optimization. We're only interested in registering a line the first time it's executed. We don't care if we go 10 times over the same line in a loop. So the very first time our own function is executed, we restore the opcode for that line to the original. So the impact of this is that only for the very first time that we go over a line, we have to go and register that thing here in our data structure. And after that, our code is out of the way. So we would expect the impact of this on CPU to be very, very small.
So what's couple? Couple?
Cover.
Yeah, the variable, it's not defined here.
No, I'm not showing all the code.
Okay.
Yeah. So does it really work? This is what we're doing now here at Booking. We're setting this up in one of our own environments, which is a web server. Without Devel QuickCover, this web server takes about 1 minute to start up. And if you look at memory usage, it goes up to about 1.7 gigabytes of RAM because we preload a lot of stuff. So we use a lot of memory anyway. When we do have Devel QuickCover, startup time is exactly the same, to the second at least. I have not found any impact. And we use 100 more megabytes of memory, which is kind of expected. It tallies up with how many files and how many lines we presume we would have, so it makes sense. So the impact is not big at all. Something else is that all the impact tends to be noticeable at the beginning when you preload 80 or 90% of your application. After that, only the code paths that go through new code will actually go through this code, through the modified nextstate opcode. Therefore, it's very, very light, so it works as we expected it. So what we do is we start up the server and we collect all these files that we were generating, as the one I showed you, aggregate them, and we have a cron job that moves that information to another server that aggregates them, and then that one server at the end. For now, the first thing we're using to manage this is generate reports with Devel Cover. Devel Cover is a Perl tool that is used to get coverage in tests. But it has all kinds of nice reports, and we decided to reuse that, to borrow that from them. We haven't told them, but. So, what are we getting? That's a kind of like the summary page. So we get a lot of files. We have like several thousand files here listed here, and for each file we get the code coverage percentage. So this is trying to tell us how much of that code was actually touched by the execution. So that's a summary, and here's one example of a real file. The square there shows how many times that line was executed. When the opcode handler only records whether the line was executed or not, so it's a bit. But when we aggregate the files, we actually add those together. So that's why we can see here numbers from 0 to who knows. So here we see several lines that were executed, and what this is telling us is that so far those 2 subroutines or those 4 subroutines have not been executed. This is an F that's checking for FCD. I would have been very surprised if this had come up green. So that part of the F is not being executed, and this part is being executed. So kind of like sanity check.
It misses the else?
Yeah, the else.
Probably optimizer way.
Yeah, here we see the interplay of the optimizer and the way Perl lays out the opcodes. So for some reason there may be here, we have seen some cases where lines that are actually semantically in our head for a human are being executed that are not shown as such.
That makes sense because most probably there's a jump from the if to the line.
Yeah.
I would imagine the if else would be in an outcome.
Yeah.
Yeah.
This is a more interesting example. It's again an if. So that condition is actually tested, but it never went into the if. It went into the else and it tested that condition twice, and it actually inside that if, that part of the if that was never executed, but that line was executed. So the long-term purpose of this is we want to see if this is a tool that will allow us to at least kind of locate lines or areas of our code that are not being executed, areas that we could maybe clean up. Of course, you can never prove that something is not executed because maybe it'll be executed once a year, who knows, but at least it'll draw your attention to the right places. I saw 2 hands raised.
Are you going to purge all of your specific code then? Or do you really want to run things on a mainframe?
I am not going to answer that.
They have a secret mainframe.
Vicente, you had a question? Again, an if that was executed twice. The condition was executed twice. It didn't go in there, but the else was executed. Then a loop. So.
How do you explain it was executed twice?
It was 2 different runs. 2 times the same page was hit.
You're aggregating the data over multiple hits.
Each file is only a bit set, but when I aggregate the files, I add the bits.
Hi, for the people who are looking at this line of code.
So, that's it.
Cool.
And yeah, seriously awesome people helped in this, and I just executed it. So, any more questions?
How much work do you think it will take to turn this into a profiler instead of just a cover?
No, this is not a profiler, and as you probably are aware, we do have profiler tools.
A very precise one. This line is really crappy.
I'm sorry?
Right, so your stat profiler and what you brought.
Yeah, it's different purposes. Yeah, this looks it looks like it could become a profiler. It's not the point. And the idea of adding the line counts is kind of like, yeah, well, we have them, so why not?
It's dead code locator.
Yeah.
And there's lots of it around here.
Yeah.
I made so much of it.
Okay, I wasn't gonna say that.
It's buried so deeply, even this will never find it.
Yeah.
Is that mainframe code yours?
All the Amsterdam stuff.
You're gonna be.
So this is on CPAN, it's on GitHub. If you find any use for it, be my guest. It's actually a very small amount of code. The heart is what you saw there, and the rest is just supporting code and the data structure to store that information. So,
Were you inspired by Sawyer playing with that other opt code where he also makes sure to run the original one and then replaces it?
in all truth, Sawyer was inspired by this.
Oh.
No, this idea is actually not mine. This came a bit before I first heard Sawyer talking about, playing around with opcodes, and it was actually Mattia who sent an email to our P5P club saying, maybe you guys, if you want to take a look at doing something kind of crazy, you could try to do this. And I thought it was interesting, and I did it. So, yeah.
It should be noted that Mattia had the entire design in his head.
Oh, yeah.
And
Yeah.
laid it out in the email.
He just didn't want to type. He probably compiled it in his head.
He core dumped it to the email.
Yeah.
That sounds kind of gross.
Oh, sorry.
There's an.
I think you could probably, instead of just looking for dead code, you could also do this if you're reviewing some code and you want to make sure that you've actually tested the conditions that the person wrote.
Yeah.
Because I know sometimes you might be reviewing something and
Yeah,
Oops, I didn't test that condition.
I have never wanted to push that idea too much because Develcover's purpose in life is that. It's you write your unit tests and you make sure
Yeah,
they have
pretend
coverage.
for a minute that you don't have unit tests and you rely on the developers to
Yeah.
actually test every
So,
page.
for certain companies that do not do a lot of unit testing, I am not going to say who they are, this could also help, yes. Okay, I'm going to run away before you get catch.